In our last video, Frankie and I focused on asking questions that we could easily answer by making further observations. Now we'll focus on a more complicated type of question: why questions. Whenever anyone discovers a mystery, we often immediately start asking why questions. Why are these plants growing here? Why did that bird not fly away even though I got close to it? No doubt you've probably had many why questions like these come up while you were out exploring.
Note that most, if not all, why questions are not easy to answer. Instead, they prompt two further questions. How can you explain your why question? And what evidence can you find to support your explanation? When you ask yourself a why question, you should first brainstorm a list of possible explanations to help answer your question. Think back on observations you made and try to integrate your previous knowledge and experience to help you compile your list. Strive to think of multiple explanations. Go beyond the tendency to hone in on the first explanation that comes to your mind. Another word for an explanation is a hypothesis. Once you have a list of one or several hypotheses, you can use further observation and experimentation to gather evidence that either supports or refutes your hypothesis.
One way to do this is to assume one of your hypotheses is true, make a prediction, and then make new observations. If your new observations don't confirm your prediction, then your explanation is likely false. If your observations do confirm your prediction, then you may be on the way to developing a working explanation backed by evidence for the pattern you've observed. But does this mean your explanation is the cause of what you're observing? Not necessarily. It's possible that your explanation may only correlate with another factor that is the true cause. Here's a statistics example that illustrates this. Smokers are more likely to die in car accidents than non-smokers. Here are some potential explanations. Number 1, smokers are more distracted by holding their cigarettes while driving. Number 2, nicotine somehow impairs one's ability to safely drive. Number 3, smokers have poor underlying health than non-smokers and are thus more likely to die when in a car accident. When researchers studied this, it turns out that none of these potential explanations are correct. What researchers found was that smokers were more likely to not wear their seatbelt. Rather than smoking, not wearing your seatbelt is what actually causes more car accident fatalities. Thus, being a smoker is only correlated with and is not the cause of fatal car accidents. While this example is from a different discipline, it is similar in that a statistic is basically just a special type of observation. Regardless of this inherent uncertainty, proposing explanations and supporting them with evidence is how new knowledge evolves, whether in science, philosophy, journalism, or in many other disciplines. Here's how Frankie and I tackled the why questions we had during each of our explorations.
While I was out exploring plants on my street, I got interested in the ivy plant growing in various places. I noticed the short roots on the stems of the vines, which led me to explore the role these roots seem to play in the growth of the ivy. I can clearly see that the ivy plant invests much energy into producing an abundance of these roots. While many of these roots helped attach the vine to other surfaces, many were also dried up and not attached to anything. So why then are some roots stuck to surfaces, but others not stuck at all? Here are some possible explanations that I thought of. 1. Maybe the roots will only stick to surfaces that have a great deal of texture. 2. Maybe the roots can only stick to surfaces near the vine. 3. Maybe the roots can only stick to surfaces when the roots are first produced. Evidence I found to support my first explanation was that roots didn't stick to the smooth surface of the metal grid reflectors or metal bar, but did attach to the crevices and cracks of the wooden telephone pole. As for my second explanation, I observed that the maximum length of the roots seemed to only grow a little over an inch. I looked at the section of branches where the roots were not attached to anything. In many cases, the stems were far away from surfaces that the roots could attach to. Lastly, I noticed that some of the roots near the ends of the ivy stem were still supple and moist. This suggests that maybe the roots glue themselves to a surface as they dry. If the new moist roots are not touching anything as they dry, then perhaps they dry out before they can attach to anything. If this is true, then this ivy produces a lot of roots on its stem that don't help it stick to anything. I created an experiment to estimate the amount of roots attached versus unattached. I measured the vines using the length of my pen and counted how many roots within that length were glued to the surface. I did the same technique to multiple random vines on a telephone pole. I found that vines had more attached roots than not attached roots. especially when it came down to areas where there were crevices. Although this experiment can be flawed for having inconsistent sampling of randomization, it gave me a quantitative assessment of the roots and how effective they really can be to certain textures of a surface. Based on the evidence I collected, I was able to support all my explanations concerning the behavior of the roots. Now I know a lot more about how this ivy plant grows and attaches itself to the substrate it's growing on. It's quite remarkable that ivy plants have two types of roots, subterranean and aerial. Very cool.
When I got to my wild land, I noticed the coyote brush and Douglas firs were commonly growing together in both the meadow and along the forest edge. This led me to question why this was the case. Maybe they are interacting in some way, or maybe their distribution is being controlled by something. Here are some possible explanations I came up with. Number 1, maybe one is protecting the other from wind, from predators, or perhaps from the sun. Number 2, maybe they are growing in a part of the meadow that is better suited for both of them. Now that I developed a list of possible explanations, I thought about what evidence I could look for to support or refute each one. For explanation 1, I looked to see if one species looked to be shading the other, or blocking the wind, or somehow protecting it from potential predators. Here's what I found. There were more Douglas fir saplings growing inside coyote brush groves than not. Furthermore, there were antler marks and herbivory signs on Douglas fir saplings that were not protected by coyote brush. For explanation 2, I looked to see where both species were growing. I first noticed that there were distinct mounds and low spots throughout the meadow. I counted the number of both species growing in the low spots and on the mounds in the meadow. Here's what I found. There was a significant difference between the number of plants growing on top of the mounds than the ones growing on low spots in the meadow. Both the coyote brush and the Douglas firs were more abundant on top of the mounds. Based on the evidence I collected, I was able to support both explanations I had come up with. I could have used a lot more time to accumulate more evidence for my hypotheses. This is what ecologists do. Making keen observations, being intentionally curious, asking lots of questions, proposing explanations, and diligently supporting them with evidence are all vital critical thinking skills that get used in many disciplines. In addition to being important, they are also a really fun and engaging way to interact with the natural world around you. Keep up this practice and you'll never be bored again. There are mysteries everywhere to observe and think deeply about.
What are the next steps in this process? There are two powerful ways to reinforce knowledge creation you've been doing in your exploration. Record your exploration in a field journal. Engage with others in discussion about what you've discovered. As part of this activity, you'll be meeting with other members of your class to discuss what you've been exploring. In our next video, we'll cover how to record your exploration in a field journal.